Because this week focuses so much on the web and internet traffic, we're going to spend a little time talking about www and HTTP. HTTP stands for Hypertext Transfer Protocol, and it sits on top of TCP/IP normally, and is a defined protocol that we can unravel right now. So let's take a quick snapshot of the architecture. The WWW, or World Wide Web, today is a distributed client-server service in which a client using a browser can access a service using a server. However, the service provided is distributed over many locations called sites. So here are the topics we're going to discuss in this section. We're going to talk about the client software, which in essence is a browser. And there are many types of browsers such as Firefox, Chrome, IE, Opera, so forth. Oh, I should have mentioned Safari for the Mac people. We'll talk about servers. We'll talk about uniform resource locators, or URLs, and sometimes people refer to this as a URI. And we'll talk about cookies. So this is a graphical representation of the architecture. Notice that you have the client sitting off by itself. This is just you or someone else sitting in front of their PC getting ready to surf the web. And before you actually do anything, the client sends a request, and their request goes to whatever the recipient server is. Like if you type in, say, test.com, it will go to test.com. It actually doesn't go to test.com. First, though, it does a DNS lookup. DNS is essentially like a phone book. It'll take test.com and resolve it to an actual IP address. So essentially, it needs to make the web request based on an IP address rather than a URL or domain. Now, the domain is actually in the HTTP header, as we'll see shortly, because the server, the recipient server, needs to know what domain was being targeted, because a lot of websites or a lot of web servers can actually host multiple domains. So then once the request gets to the server, which in this diagram is Site A, assembles everything and sends it back. Now, I've oversimplified all of this because no web page is a single resource. Well, that's not true. Maybe one or two on the web now. It used to be they all were. But so you have an HTML page, then you have maybe CSS, which stands for Cascading Style Sheets, maybe some JavaScript, external JavaScript. All the images are going to be external. So in this case, web page A is really a collection of documents that gets returned. At the same time, the client can make a request to a different server, and when I do my research, I typically have maybe 6 or 8 or 10 web browsers open because I'm making requests to a lot of different sites. But server B does the same thing. It gets the request, it knows what it's looking for, and it uses the HTTP header to figure out what to send back to the requesting machine. So then it sends back the collection of resources. In this case, it's labeled web page B, but it's really collection B. So the browser actually has quite a few different moving parts. There is a controller, and we normally think of the protocol that we use over the web through the browser as HTTP, Hypertext Transfer Protocol. And that's going to be a large majority of what it does. However, there are other protocols that the browsers can actually service, one being FTP, File Transfer Protocol, and its purpose is really to send and receive files. And usually when you access FTP over a browser, it's usually retrieving files rather than sending them. Normally when you send files over FTP, you usually get a dedicated FTP client such as FileZilla or something. Telnet is another protocol, And we actually touched on that when we talked about email, because in email we said that we could even go through a whole email conversation on our own just by typing in the correct telnet commands, which represent the email commands. SMTP, Simple Mail Transfer Protocol. So all of these and more are protocols that you can use the browser to talk with. Now, remember I said that a web page was actually a collection of resources. And the wrapper resource is going to be HTML, essentially. And actually, you could have multiple HTML files as a part of any kind of request. Normally, though, there's one single wrapper, and there might be inner HTML pieces. There might be what are known as iframes or other types of embedded assets. JavaScript is the programming language that web pages use to make them active or to do interesting things. For instance, JavaScript, many times it's used to activate a link. When you hover over a link, it does something interesting. Now, Java is totally different than JavaScript. I have a lot of people who think that they're the same. JavaScript is basically, it's a text-based language that you can actually go ahead and see when the payload gets back to the client. Java, on the other hand, is more like a compiled language. It compiles into these things on the web called applets, or it can actually get compiled into these things on the desktop called applications. Java isn't actually compiled to native code. It's actually compiled to intermediate code. And this intermediate code then is platform independent and can run on Macs, Sun Solaris, Linux, Windows, anything that has what's known as a Java virtual machine. So HTML, JavaScript, and Java actually are able to perform things. It's different than images. Images simply are just static resources. HTML, JavaScript, and Java actually you might think of as interpreters. So let's talk about the anatomy of a URL. So it always starts with protocol. And in most cases for us, for the web browsing, it's going to be HTTP. So almost everything we do is HTTP://. Now, the change in that, HTTPS, means it's over a secure socket layer. So HTTP and HTTPS are extremely similar, except with the S, it means that all of your communications will be encrypted. Now you might be thinking, well, I type google.com in the address line all the time, and I never type HTTP://. That's because if you don't type anything, then your browser is going to imply that it's HTTP protocol. A lot of times when you type in, say, google.com, the browser will actually insert that for you on your behalf. Okay, the host is going to be essentially the domain. It might also be a subdomain, but it might be google.com or microsoft.com. So those are root level domains, but if it's a subdomain, it might be say like sourcecode.microsoft.com or source.microsoft.com or docs.google.com. So the domain, the root level domain will be google.com, microsoft.com, ricklineker.com, but then you can have subdomains such as docs.google.com and so forth. Now the port actually is optional. If you don't put a port and the protocol is HTTP, it's assumed that it's 80. If you don't put a port and the protocol is HTTPS, it's assumed that it's 443. So the only time I've ever used a port is when I had to set up something internally that used a different port so that I didn't conflict with other applications. And that is a very rare thing. I can only probably remember, say, 6 or 8 times in my whole life when I've had to configure a port. And then / whatever the path is. Now, you don't need a path, but normally you'll have a path such as / some directory / view.html or something like that. If you don't have a path, then all servers have what's called a default document, which the network admin or the web server admin sets up. And most of the time that'll be index.html or default.aspx or something like that. So if you don't type a path, it will default to these default documents. But a lot of times you'll see a path in the address line. So web documents. The documents in the World Wide Web can be grouped into three broad categories: static, dynamic, and active. The category is based on the time at which the contents of the document are determined. This is very important, and even to this day, I know so many technologists who don't understand these differences. So this is really important. So now we're going to sort of tackle these three subtopics: static documents, dynamic documents, and active documents. So a static document. These are the oldest type and the easiest to understand. A client makes a request to a server. The server looks to the hard drive. It might be something like about.html, and it's just a single HTML document, and sends it back. And there's nothing special about it. It's just a file on the server's disk. And so the server loads it up and sends it back, and the client gets it, and the browser renders it. Easy. So these types of documents have what are known as tags. Notice in this example, B stands for bold, /B means end bold. So you always have, they're always a matched pair. That's not actually necessarily always true. Now in the day of XML, we don't necessarily have a start and an end tag. But let's just for right now, for the sake of argument, say that most tags have an open and a close. So B, /B, I would be italic, /I would be end italic, U would be underlined, /U would be end underline, and so forth. And that way, when you're designing your HTML content, your static content, it's really easy to sort of stylize it. So where it says B, this is the text to be boldface /B, the browser actually will render it in bold since it knows that B means bold. Now, to be clear, there's another tag that is synonymous to B and is somewhat preferred at this point, and that's strong. So B, the bold tag B, has been somewhat replaced by the tag strong. So we have beginning and ending tags. There's the tag name. It starts with less than tag name. And you got to be careful because it's really picky about not having a blank space between the less than sign and the tag name. Remember, what we already saw was B was the tag name, and I mentioned I and U as tag names. Okay, so these tags can actually have attributes that have a meaning. The attributes might be like a color or a font or something like that. And really there's no technical end to how many attributes a tag can have. Finally, you end with the greater than symbol. That's a beginning tag. An ending tag doesn't have any kind of attributes. It's always formed the same way. Less than symbol, / the tag name, and a greater than symbol. So that's how you know where a tag starts and where a tag ends. And I can't tell you how many sloppy HTML files there are on the web where these have been somehow messed up. A lot of people, go to college or high school and they learn how to do web pages. And even professionals sometimes mess these things up. I find myself every so often forgetting something. So anyway, just be really careful. And when you're looking through these files, when you're doing an examination, always look for the start and end. So you can create a dynamic document using CGI or even ASP or ASPX or PHP. I mean, CGI is probably the oldest way to create a dynamic document. Nowadays, it's mostly PHP and ASPX. PHP normally is going to be on a Linux server. ASPX is usually going to be on a Microsoft server. But the client makes a request just like it did with the static document, and then the server knows that it's a special type of request. The server knows that that request means it's going to spawn a program and it's going to on the fly create that document. It's not like some web designer created this static document that the server just pulls off the hard drive and sends. This time the server has like a template file, which is actually the CGI, PHP, or ASPX files. And it goes ahead and uses those files then to do a custom render depending on the situation, and then send it back. So once it sends it back, the client doesn't know that it's dynamic. The client just knows it got a web page. The server is the only side that knows it's dynamic. So the server takes the request, renders it, and renders it in a custom or on the fly method, and then sends it back, and the client just sees the document, doesn't know that it's dynamic at all. So essentially these are created with sometimes what's called server-side script. In a way, PHP is server-side script, but ASPX is more of a compiled server-side application. Yeah, it starts off as kind of a script, a source code, but then the server actually compiles it. So I think at one time it was all script, especially ASP, PHP, and there actually used to be, IBM had a server technology that actually used Java to create dynamic HTML documents. But the days of really saying it's a script are kind of over. More than anything, it's really more of a compiled program on the server side that's doing the work. So let's note that dynamic documents are sometimes referred to as server-side dynamic documents. And if I were to guess, I would say that probably a good number of internet documents are dynamic. Now, here again, it's really hard to make blanket statements. There's another technology that is a hybrid between these dynamic documents and what we're going to talk about pretty soon using JavaScript that uses a technology called AJAX. So that's a newer technology, newer meaning 10 or 12 years old, but still, compared to these other technologies, is kind of new. So I'm hesitant to give you a blanket statement. However, I just did. So active documents can use a Java applet. So the server, as one of the resources that gets sent back as part of the request collection or group, or whatever you want to say. One of the things that can get sent back is a Java applet or a Java applet and support classes. A lot of times there are multiple files, or jar files, or class files, or kind of fill in the blank there. There are a lot of variations of that. And the client actually runs this applet on its end. So now it knows that there's something dynamic. It knows that this applet is running. Applets are really fading pretty fast just because JavaScript is easier and better, and the applets could represent a security risk. So I think there's going to be a day when you probably don't see that many applets getting served up. So client-side script is really where the money is today. It's JavaScript. And I tell many of my computer science students that for the next 5 years, the JavaScript programmers are going to own the world. Right now, it's really, to be a JavaScript programmer, it's the hottest skill set for getting a good job. I know that C++ and C# and Java and Python, all those are there, and they're never going to go away, but sort of the hot skill is JavaScript. Essentially what happens is JavaScript gets delivered to the client as part of the request resources. And it's nothing more than text. JavaScript is nothing more than text. that the client then either interprets or compiles on the client side. And at one time it was real-time interpreted. Now it takes it and it actually does a real-time compile. It does what's called a just-in-time compile. So as soon as the client gets the JavaScript, it actually does compile. And then the things that the JavaScript can do is it can make user interface objects active. It can maintain content. It can rotate images. It can do fancy menus. There is just a lot of stuff that you can do with JavaScript. I rely on JavaScript heavily for everything I do in web applications. So here's a note. Active documents are sometimes referred to as client-side dynamic document. You really should be side, not site. So now let's talk about HTTP, or Hypertext Transfer Protocol. This protocol is used mainly to access data on the World Wide Web. HTTP functions as a combination of FTP and SMTP. So what we're going to talk about is HTTP transaction and persistent versus non-persistent connections. So here's a note. HTTP uses the services of TCP on both well-known port 80. HTTP uses the services of TCP on well-known port 80. And the corollary is HTTPS uses the services of TCP on well-known port 443. So here is a transaction. The client sends a request to the server, and the server sends back a response. Now, bearing in mind the response, as we've already said, might be a collection of documents. Now, bearing in mind that the response might actually be a collection of documents that are wrapped within an HTML document. So, there's a request line, such as, so there's a request line, which we'll see more in detail in a minute. There are any number of headers. There's a blank line, and we actually saw a blank line in the email protocol too. So this extra blank line is one of the ways on the web that a separation is signified. And then the body. And the body is actually what you see when you go to Firefox or Chrome or IE and you say view source. You'll actually never see the HTTP header, although you can get utilities to see it. But the body is normally the thing that starts with the HTML tag and ends with a close HTML tag. So that's the request. Then the response has a status line. It has its headers. Here again a blank line and the body. So request and status lines. The request type, and the request type could be a GET or PUT or other similar things. There's a space, there's a URL, and then there's HTTP version. And the HTTP version is sometimes important because some of the newer features are not supported in older features, are not supported in older versions. So a status line is an HTTP version, a status code, and a status phrase. So methods are get, head, post, put, trace, connect, option. And get and post are going to be the two most common ones. Get being even more common than post. So get requests a document from the server. Head requests information about a document, but not the document itself. And the reason head is important is because your browser is going to cache the content, such as images and stuff, on the local computer. And this head thing is going to get the time and date of whatever, say, an image is and compare it to what's on disk, and only get the full image if it's out of date. Post sends some information from client to the server. It also can get information as a response from the server in response to whatever data was posted. And normally we think of, say, JSON or XML data being posted to a server. Put sends a document from the server to the client. Trace echoes the incoming request. Connect is reserved. An option just inquires about available options. And this is necessary for when you want to make sure the server and a client are both sort of aware of each other's are aware of each other's capabilities. Status codes, 100 and 101. 100 is continue. That means that the initial part of the request has been received and the client may continue with its request. Switching means the server is compliant with a client's request to switch protocols defined in the upgrade header. And the more common codes and phrases are 200 for OK, the request is successful, 201 created, 202 accepted, 204 no content. So here are a lot more status codes. 301 move permanently, 302 move temporarily, 304 not modified. And that not modified thing is really important because then the browser can use what's cached on the local computer. Now these next several codes are really bad because it means you're not going to get anything back. 404 is the most common of these, not found. For instance, if you mistype a URL, you'll get a 404. Bad request is, so these are all bad, but 404 is one you're going to get more often than anything. And on the 500 range, the one that I normally get when I am writing software and debugging my code is 500. That's when maybe one of my ASPX pages doesn't compile and I have some sort of syntax error on it. So any of these 500 codes are really, really bad. So here's sort of the anatomy of a header. So you have the header name, colon, a space, and then the header value. And even though most of the parsers will let you get away with not having a space, I would actually respect this because you're going to somewhere along the way have someone who wrote, say, maybe like an ISAPI DLL or something, and they don't respect that. So this has to be actually respected. General headers, cache control specifies image information about caching. Connection shows whether the connection should be closed or not. Date shows the current time date. MIME version, we've already talked about MIME types. So this is just going to tell you what the current MIME version is. And upgrade specifies the preferred communication protocol. Okay, and I'm not going to go through all these. What I'm going to do is just sort of pick and choose. Host would be the one you really need to pay attention to. That's where the domain name is going to go. The domain name will go under host. Remember we said that when the browser makes a request, it's actually going to make a request based on an IP address, which it looked up in DNS. But still, the server needs to know what the domain is because many servers are hosting multiple domains. Let's see, refer is not always used. Refer is actually how a web server knows what page you came from. So when you first type in www.google.com/ say docs or something, you don't have a refer. However, when you're coming from another page, you'll get a refer usually. And those are the two most important ones here. User agent is interesting if you're collecting statistics. It'll tell you what the browser type is. Response headers. These can be helpful, but most of the time I ignore all of these. I've never really used the response headers for anything. I've looked at them, but I've never found much to be much useful information here. Entity headers, however, are quite a bit different. So allow, list valid methods. Content encoding specifies the encoding scheme. That might be like a ASCII 8 or ASCII 7 or whatever. Content language, that's important. Content length is very important. This is actually kind of an optimization. It's part of the HTTP header, but it tells you how many bytes the actual content is. Okay, content range specifies the range of the document. Let's see. Expires and last modified are actually pretty important. So here's an example. In this example, we're going to retrieve a document. We'll use the get method to retrieve an image with a pass /usr/bin/image1. The request line shows the method get, the URL in the HTTP version 1.1. The header has two lines that show that the client can accept images in the GIF or JPEG format. The request does not have a body. The response message contains a status line and 4 lines of header. The header lines define the date, server, MIME version, and the length of the document. The body of the document follows the header. Okay, so here's actually what that looks like. So there's the request. Okay, and there are 2 types that we'll accept. Okay, and the reason it's going to accept them is because it's requesting an image. Okay, and then what it gets back is the HTTP version, the status text, the time and date, the server, the MIME version, and the content length. And of course, what isn't shown here is the body of the document. The content length is 2048, which is actually plenty to give you some sort of a simple HTML response. So here's another example. The client wants to send data to the server, so we're going to use a post method. The request line shows the method post, URL, and HTTP version. There are 4 lines of headers. The request body contains the input information. The response message contains the status line and 4 lines of headers. The created document, which is a CGA document, is included as the body. Okay, so the only big difference here in the request header is that this is a post and not a get. It's going to accept star.star or anything. It's got image GIF, image JPEG, and then it's got content length of 50 because it is actually, since it's a post, it's actually going to send some content. The request it gets back is very, very similar to the last one that we saw. Now, you don't know, you never actually see the CGI or ASPX or PHP code. That never actually leaves the server, but this generated HTML document is what leaves the server. So here's another example. HTTP uses ASCII characters. A client can directly connect to a server using Telnet, which logs onto port 80. The next 3 lines show that the connection is successful. You can then type 3 lines. Okay, the first line shows the request line, the second is the header, the third is a blank. The server response is 7 lines starting with the status line. The blank line at the end terminates the server response. The file of 14,230 lines is received after the blank line. Okay, so here's the Telnet conversation. Okay, the first line is actually Telnet connecting to that server on port 80. Trying, then it says connected. And then if you type get space /engcs/compsci/Feruzin space http/1.1 from so forth, it will give you an actual response as if you were a web browser. So there's nothing really magic about web browsers. You can do the same thing with Telnet and get the same kind of a response. So here's a note. HTTP version 1.1 specifies a persistent connection by default.